Hi guys, okay, so let's continue on with the rest of the brain. So cerebrum, we said there were 5 parts, right? There was the frontal lobe, there was the parietal lobe, there's the temporal lobe, there's the occipital lobe, and hidden underneath is the insula, which is a landmark for basal nuclei, and they initiate movement, right? So we're going to go a little bit faster because we had this already. We kind of talked about this. Gray matter is unmyelinated. Usually you're going to see it in cell bodies for processing information. White matter is myelinated, and you see that typically in axons that are transmitting or sending information. So what do we have? The insula. We said the insula was hidden on the inside, right? And it's a landmark structure or a landmark for basal nuclei which initiate movement. So some of the things that we're gonna highlight is central sulcus. Don't worry about lateral sulcus. I won't test too heavily on that, but I do want to test on central sulcus and talk about the frontal lobe versus the parietal lobe. So central sulcus is great because it's a landmark for division between the frontal lobe and the parietal lobe. And so I like to draw my baseball mitt, right? This guy is the central sulcus, right? Over and over again. This one is gyri is high, gyri is high. Because this is in front, it's mev, right? And because this is behind, it's sad. So if I take a look at these guys, this is called the primary motor cortex, and it's a part of the frontal lobe. This guy is called the primary sensory cortex, and it's a part of the parietal lobe. But we already knew that, right? We said, pry your brain open when your parents are annoying you. You're too sensitive to it. Temporal lobe is here, occipital lobe is here, insula is hidden underneath as the landmark for the basal nuclei for initiating movement. So we already have this down. We said that the post-central gyrus is for the primary sensory cortex, and the pre-central, pre referring to front, referring to ventral, post referring to back and dorsal. So that's pretty easy. You guys got that down. Here's a image of what the terminology is referring to. Central sulcus divides the frontal lobe from the parietal lobe. If you guys do want to understand this, lateral sulcus is just a line right on the side. So I draw this line here, right? And it is a division between the frontal lobe and the temporal lobe. And you guys can review some of these other structures. But landmark, if you follow this and you're able to actually find a line that starts from the top and it makes its way all the way down to touch the lateral sulcus, basically to touch the temporal lobe, then that's the central sulcus. If there's an elevation in front, that is precentral, that's for motor, and that's a part of the frontal lobe. If it's an elevation behind, it's post-central gyrus, right? So it's referring to SAD, or sensory component of the parietal lobe. And then same thing, so it's just a lot of this is going to be repetitive for you guys. Just understand that repetition is always good. Insula, landmark structure for the basal nuclei, which initiate movement. This guy is a new one. So do you still see the chicken though? I totally still see the chicken. So I see the chicken with the chicken eye, his little eyebrow, right? And then hidden underneath that we can't see are the 2 lateral ventricles, and they help to wash CSF and nutrients all over the brain on the inside. And then it travels through the cerebral aqueduct into the 4th ventricle, then it passes out the lateral and median apertures into the subarachnoid space, etc. So you guys can review that from the other video. But this guy is the hard body. It's called the corpus callosum. And what's the significance of the corpus callosum? Well, imagine a connection between the right and left brains, right? So I have a connection, and imagine that now I have a seizure. So typically this connection would allow the communication between your right and left brain. Your right brain controls your left body. Your left brain controls your right body. Now there's communication between the two so that I can coordinate the right and left sides. If I have a seizure, and let's say it starts off in the right, and it's only on the right side, but as soon as the seizure hits, it travels through what we call the corpus callosum and some of the other communicating fibers, and then it passes through the left side. Now you have a seizure on both the right and left side. You're completely debilitated. You're out of commission. So what do? If the drugs that we talked about before, the seizure meds that deal with, I would say when you guys get a chance, even anxiolytics work this way. So we said, this is a review to remind you over and over again that these ions are essential for understanding medicine. Why? They are what make up the function of the cell. If you don't understand this concept, then you're going to have a hard time, especially when it comes to drugs. You'll just memorize it. But you know what? If you know the mechanism, then you can see what's going on and you can predict what the side effects might be. So sodium moves into the cell to turn it on, calcium can move in, potassium would move out to turn it off, and chloride would move in to turn it off. So if I block sodium, then I can't turn on the cell, right? That's a seizure med, a medication that stops a seizure. What is a seizure? A seizure is overactivity. So now if I turn off the cell, it's not active anymore, you don't have the seizure. If that doesn't work, then you can use GABA. And GABA, 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 do you want me to stop? GABA, 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 do you want me to stop? GABA, 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 GABA. I hope you said yes. Okay, so GABA does this. It has two channels. It has GABA A and GABA B. GABA A and B deal with the movement of chloride into the cell to turn it off, or kicking out more potassium to turn it off as well. So GABA A, so let's write a GABA A receptor and a GABA B receptor. How I remember which one is associated with which ion is B almost looks like the letter K. So if you were to complete the letter K on the top and the bottom, it would be a B. So therefore, by default, chloride is associated with A. And that's how I remember it. This is more advanced. You're probably not going to study it, but it's really great to know. And I'm speaking a little bit faster because I realize you guys can always rewind this and watch me over and over again. So if I speak too slow, then I'm going to get bored. And if I speak too fast, then if I speak too slow, then you're going to get bored too. So if I speak fast, then you're going to have to rewind it and watch me over and over and over and over again. Oh, poor you. So here we go. We have GABA receptors, and this is for seizure. But if the seizure meds don't work, right, the whole point is this. The corpus callosum means hard body, and it's a connection between the right and left brains. If I cannot control the seizures, and I am to a point where I need something to make sure that the right brain doesn't affect the left, and at least diminish the consequences of having the seizure, I can sever it. So I cut the corpus callosum. I basically sever the communication between the right and left brains. What's the problem with that? Well, the good thing is now I don't have seizures being communicated between the two hemispheres, right? So at least I minimize the amount of consequences that we have for it, right? But now I can't coordinate my right and left bodies. I have to relearn and retrain myself to communicate and understand what's doing what. So there's that resolution, but at the same time there's the problem of not being able to communicate between right and left bodies because you're not communicating between your right and left brains. So here we go. This is the hard body, corpus callosum. Here we go. And communication fibers, these are essentially, let's take a look at what they are. The corpus callosum was the hard body. Anterior commissure is a smaller version. It communicates between the right and left hemispheres as well. So there is another bypass that can communicate a little bit between the two. But what do we say for questions? What is the corpus callosum? It means hard body, and it's a connection or a group of axons that send signals between the right and left brains. Internal capsule is another group. This one is pretty important. We'll talk about that when we get to it, but here we go. Communicating fibers just connect the different parts of the brain to each other. All right, here we go. Corpus callosum and anterior commissure. So if I was to sever the corpus callosum, I still have another pathway, but it's not as big as the corpus callosum. So even if you have seizure and you have communication through this pathway, it won't be as significant as if you still have the corpus callosum. So basal nuclei, what do they do in general? All I want you to remember is they initiate movement. In general, they initiate movement. What are the basal nuclei? These are considered the basal nuclei. So what do they do? In general, initiate movement. However, for class, I'm going to make you memorize the different parts because this is anatomy, right? So the corpus striatum, let's draw out what it is. I'll show you an image of what it looks like on cross-section. So this is what we call the internal capsule. The internal capsule is a bunch of lines, right? And they are communication fibers that send information from other parts of the brain up into the cerebral cortex. So it could go up to this region here, it could go up there. It basically communicates to different parts of the brain. And it passes through the basal nuclei. So it has a very distinct characteristic look to it. Almost looks like an angry guy with little eyes and somehow something going on over here. Okay, so there's three parts to the basal nuclei, and the three parts are this. You have a caudate nucleus, which is the tail end of something. You have the internal capsule, right? So this is caudate. You have the internal capsule, which is a bunch of lines or striations that pass through. Then you have the Globus Pallidus and you have the putamen. So Globus Pallidus is the tiny little guy. So we're going to write Globus Pallidus. You guys can go back for spelling. And this is putamen. And these together in general are called the basal nuclei. As a whole, though, for descriptive purposes, this is corpus, meaning body, striatum, meaning lines. So this is a lined body. If I look at all of them as a group, they're called the lined body or corpus striatum. If I separate two of them, because these guys almost look like they're connected to one another, right? So we're going to label these guys a special name. So we're going to call them the lentiform nucleus. Why did they name it that? I don't know. It's probably to make it just a little bit more complex, right, for you guys to study. No, I don't know if that's the reason. It's probably not the reason. So lentiform nucleus is the combination of the putamen and the globus pallidus. Yes, test questions, fair game for you guys. Corpus striatum is basically the entirety of it. So if I have a test question for you, I'm going to say what two are part of the lentiform nucleus, and it would be putamen and globus pallidus, or I could say something like, which one is not a part of the lentiform nucleus, and the answer would be caudate. Caudate referring to tail, so it's the tail end of a nucleus, or it is the nucleus that looks kind of like a tail if you look at it from a different direction. So here we go. So the questions were answered. You guys know what this is. What is corpus striatum? It's the lined body. It includes all of these plus the internal capsule. Lentiform nucleus is just globus pallidus and putamen. Okay, so continuing on. What is the function of basal nuclei? We said initiates movement. We're simplifying it down to this. Look at this. Coordination of learned movement patterns. That's initiating movement, right? What nucleus is associated with the production of dopamine? And we said that was substantia nigra. Right, and if I have a deficiency in substantia nigra release of dopamine, basically a deficiency in dopamine, what condition is that? And that was Parkinson's. And how do I treat? I give them dopamine? No, I told you we have to give them L-DOPA so that it can cross the blood-brain barrier and then be converted to dopamine and used through the pathway to replenish the dopamine that's absent. And then it helps. So if I have tremors, I have something called tardive dyskinesia. I have a dysfunctional gait. That means maybe everything is jerky. The movements are jerky. Then what happens when I give dopamine? It does the opposite. It helps to smooth things out. And so we talked about deep brain stimulation. And deep brain stimulation was putting electrodes into the brain to stimulate the same pathway for people that have Parkinson's and they have tremors, right? Or even patients that have idiopathic or unknown origin tremors. They can still go in with this deep brain stimulation, put the electrodes in, start to stimulate with electricity, and then trigger the pathway to smooth out. What else do we have? We said precentral was MEV. Postcentral was SAD. Visual is occipital. Auditory was temporal. Olfactory, gustatory, so cranial nerves 1, and then this is actually 7 and 9. We'll get to that later.